Okay, we want to solve this question. We want to derive the Laplace transform. And again, we know if we have signal xt, then its Laplace transform equals integral of xt times e to the power of minus st times dt from 0 to infinity. Well, this is saying that t is between 0 to infinity, okay? And in this range of values for t, we can conclude that ut is 1, because ut is either 1 or 0. It is 1 if t is equal to 0 or is larger than 0, and it is 0 if t is smaller than 0. So it says this is the unilateral Laplace transform, so it says t is equal or larger than 0, and that means y of t is always 1. And when we know that, we can simply replace this guy here by 1. So I can write x of t equals cosine of omega 0t. So let's calculate the transform function. The Laplace transform for this signal. Okay, so x of s equals integral from 0 to infinity of cosine of omega t dt. Okay, I can write cosine of omega t using Euler angle. Let me write that here. Let me write it here. I can write the cosine of omega t equal to 1 over 2 times e to the power of j omega t plus e to the power of minus j omega t. Okay. So if I replace that, okay, so fortunately no one correct me, and we have e to the power of minus st here, not dt simply. So I replace that here, then we have x of s equals integral from 0 to infinity of, and instead of cosine, I write the Euler equation, 1 over 2 times e to the power of j omega t plus e to the power of minus j omega t. This is omega 0, of course. Times e to the power of minus st dt. If I further expand this, then I would have x of s equals 1 over 2 times integral of 0 to infinity of e to the power of. So if I multiply this to this, then I would have e to the power of j omega minus s times d. J omega minus s times t dt. So what I did is I just, well, this is just the multiplication of e to the power of j omega t and e to the power of minus st. Okay, so I can write this as e to the power of j omega t minus st, and then I can further simplify that and write it t times j omega minus s, or minus s plus j omega. I can do the same. I can do the same for this part. I can multiply this to this, so, and I can decompose that. So this is integral from 0 to infinity of e to the power of minus j omega t plus, minus j omega plus s times t. dt. And what I need to do is to just simply calculate these integrals. So I would say x of s equals 1 over 2 times, well, the integral here is 1 over j omega minus s times e to the power of j omega minus s times t, okay? 1 over j omega minus s times e to the power of, so let me write it up here, e to the power of j omega minus s times t, and for this t equals from 0 to t equals infinity, plus the integral for this part, or the second part, is minus 1 over j omega plus s times e to the power of minus j omega plus s times t, okay? This is minus, or I can take that out. Or maybe, but just for better understanding, maybe we can just leave it minus here, minus e to the power of minus j omega 0, these are all omega 0, plus s times t divided by j omega 0 plus s. Again, the value of t is in the range of 0 to t equals infinity. So I need to calculate this. Well, we have done that before in, I think, I can't remember which question it was, but that's pretty simple, I think. Well, we can write it at 1 over 2 times. Well, if I replace infinity here, we would have 0 at the denominator, and if I replace 0 at the denominator, we would have minus 1. Okay, so we have 0 minus 1 over j omega minus s plus we have minus 0 plus 1 over, if I calculate the integral, if I replace t equals infinity and t equals 0, then I would have 1 over j omega plus s, okay? Well, now I can further simplify this. If I further simplify this, I would have 1 over 2 times minus 1 over j omega 0 minus s minus, plus 1 over j omega 0 plus s. So this equals 1 over 2 times, if I multiply these two, I would have j omega minus s, j times j omega plus s, and then at the denominator we would have minus j omega minus s plus j omega minus s, okay? So you see, let me use different color, I made it too easy here. So this guy cancels this one here, okay? So let me write the rest in the next slide. So if I Move everything to the next slide, we would have x of s equals 1 over 2 times j omega minus 0 times j omega plus 0, j omega 0 minus s times j omega 0 plus s. And at the denominator, we would have minus times 2s. Okay, so simply these two cancels each other. This one and this one cancels each other. And if I do the multiplication here, what we would have? Well, we would have j omega 0 times j omega 0 plus j omega times s minus j omega times s minus s squared. So again, you see these two cancels each other, and this one is very important. This equals j squared omega 0 squared. And we know that j squared, j equals square root of minus 1. So j squared is minus 1, okay? I replace that here. So this becomes minus omega 0 squared. Now I can write this equals minus omega 0 squared minus s2 squared, or minus omega 0 squared plus s2. So I replace everything here. We have minus s times minus omega 0 squared plus s squared, not s0. Sorry. This is s squared, okay? So again, this sign here, let me use different color. This sign here cancels this one here, so I can finally write down xs equals s over omega 0 squared plus s squared. And this is the Laplace transform of a signal xt equals cosine of omega t u of t.